Hello, everybody. It's Mr. Yosef again. Today, we're going to focus on doing some practice problems and factoring. So, if you're looking at we do something called a trainer mode. So, we just have some random problems on there. So, I'm just going to do a couple of these problems on here that I feel like will be beneficial for students. So, the first one I'm going to look at is 7x squared plus 53x plus 28. I like this problem because the numbers are a little bigger, so it does pose a challenge. One thing that I would say makes it a little less challenging is the fact that they're all positive signs. So this looking at a problem being to identify certain things can be really useful when you do this. So first thing that I always do is I'll check for greatest common factor. So is there any uh, numbers or variables that they all have in common that I can take out? So 7, 53, 28, nah, it doesn't work. So that means there's not a number that I could take out. So next step, I know my product is 28. So what I like to do is I just like to list out all the ways to multiply to 28. So 1 times 28, and 2 times 14, and 4 times 7. So there's sort of tricks that you can learn that helps you identify these quicker, but it just honestly just takes practice. So we know 28 is our product, and somehow we need to add to get 53. So we call this a sum and product. However, we know something is different about this question when calculating a sum because of this a value. So this a value has an effect on the sum. So what I'm going to do is I'm going to write my two parentheses, and I'm also going to think about how can I multiply to 7x squared. So the nice thing about this is the fact that 7 is a prime number. So since 7 is a prime number, there's only one way to multiply to get it. So that's why I'm going to write a 7x and an x. You're going to see later on in the video, I'll do an example where the a value is not prime, so we can see how to deal with more options. So we know it's 7x times 7x, and we know that these are both plus signs, and we also know that it's either going to be 1 and 28, 2 and 14, or 4 and 7, and in some order. So what I like to do is go ahead and write my arrows. So I know that 7 times whatever number is here and whatever number is here times this, I know that these two will give me my sum of 53. So when I'm looking at my options of 1 and 28, 2 and 14, 4 and 7, you can blindly pick one and just plug it in and check if it works. So I'm just going to go ahead and do that real quick. So I can write 1 and 28. But I hope you see already that this is not a good idea because 7 times 28 is such a huge number. That's not going to give me a 53. So I'm not going to even bother and calculate that. So let me be a little more tame. So 7 times 14 or 7 times 2, that potentially could work. But if I do 7 times 2 here, that gives me 14x. And if I put a 14 here, this gives me 14x. And 14x plus 14x is 28x. So this still also doesn't work because we want our sum to be 53. So I'm just going to erase that. So a lot of people call this annoying, honestly, having to go through all the different factors. But with enough practice, you'll start noticing things. So for instance, the first thing that we should have started with is 4 and 7, because 7 times 7 is 49. So this 49 is close to 53, and I know the second number is 4, and 49 plus a small number is a higher likelihood of getting 53 than picking any of the other possibilities that we chose. So here we see that 49x plus 4x does equal 53x. And I hope you also notice that I'm only checking the inside because 7x times x is 7x squared. 4 times 7 is 28. We did that hard work at the beginning of the problem, so all I'm doing is focusing on the middle. So that is what I would do for this problem. So let's try one that doesn't have a prime number of a. So a great example would be 16x squared plus 38x minus 30. I like this one for a lot of reasons. First of all, they're not all positive. Second of all, the numbers are decently big. And third of all, 16, there's so many ways to multiply to 16. So if you pause this video and ask yourself, what is the first step I should always do? Pause it and figure it out. Unpause, and I just heard you say greatest common factor. Yes, that should be the thing that you should always look for. So when I look at 16, 38, and 30, I know that all these numbers are divisible by 2, so I can factor out a 2. And then I'm asking myself, 2 times what gives me 16x squared? 8x squared. 2 times what gives me 38x? 19x. And 2 times what gives me negative 30? Minus 15. So now we are left with 8x squared plus 19x minus 15. So a lot of students, I'm going to put my smiley faces, a lot of them do this because they think they're finished. I'm sorry, you can still smile, but we're not done yet. Because now we need to look at this inside part and ask ourselves, is this something that we can factor? So we're going to go through the procedure that we went through earlier. So first thing is 15. What are all the ways to multiply to 15? 1 times 15, 5 times 3. So that is my product. My sum, I didn't write this last time, but you can write 19. And then your A value is 8. And if you think about 8, there's 2 ways to multiply it to, so technically your A value is 8, but we're trying to multiply to 8x squared. So technically there's 2 ways to multiply to 8x squared. We have a 4x and a 2x, and we have an 8x and an x. So we don't know which one is correct, but we know that this is a possibility here. So my suggestion always is if the number in the middle is not too big, or there's not like a striking relationship between the 8 and the 1 and the 19, if there's not something obvious, like is it 8 times what? It's like 8 times 5 gives me 40, that's too big. 8 times 3 gives me 24, that's too big. So 5 and 3 don't work here. Most of the times you want to start with the smaller one. So we're not going to start with this bottom one. We're going to actually start on the top, and we're going to start with 5 and 3. So the funny thing about this question is I always tell you to pick the smaller one, but the answer is actually going to be the bigger one. So the answer is actually going to look like this. But hypothetically, if we're doing this question and we were going to do the probability, it would most likely be 4x and 2x. So let's try this out. So 1 and 15. If I put 15 here, 4 times 15 is 60. And if I put a 1 here, I get 2x. It doesn't even matter about the signs here because that's just too big. So I know that's not right. Quick swap. 15, 1, 4x, 30x. Once again, it doesn't matter if this was positive and this was negative. 4x minus 30x is negative 26x. That doesn't work. So, okay, that doesn't work. But if you asked me at the beginning of this video, I would have not tried 1 and 15 first, just because the numbers are just, 15 is too big. 15 just affects this problem in a way that makes it hard. So I'm going to try 5 and 3. So in your head, it is just hard to visualize, okay, 4 times this times this. So 4 times 5 is 20. 3 times 2x is 6x. So even if I made this positive, made this negative, 20 minus 6x doesn't give me 19x. There's no way 20 and 6 could give me 19. So that doesn't work. So let me just try to switch the spots of the numbers. Let me put a 3 here. Let me put a 5 here. Let me erase this. Let me erase this. So you get 12x and 10x. So this happens to be negative. So 12 minus 10, that's 2. So that doesn't work as well. So even though most of the times we say the smaller numbers, the ones that are closer together, most of the times work, in this case, it doesn't. So that leads us to go to the bottom one, 8x and x. So we got to be strategic here. So we want to get a 19. So if I do 8 times 3 here, I want you to think. I'm not going to do 8 times 5 because that's just going to be too big. But if I do 8 times 3, let's make it positive, that gives you 24x. This gives you a chance because 24 is somewhat close to 19. And I know that this number needs to be a 5. And 5 times x is 5x. So let's think about it. Do we want 5 to be positive or negative? Well, it has to be negative because our product is actually negative 15. So if our product is negative 15, we know the signs always have to be plus or minus in some type of order. And if you put a negative there, you get 24x minus 5x, which does give you 19x. So this one does work. So one improvement I would say that I should have mentioned when I'm doing this process is I should have asked myself about the signs. So because our product was negative, I know it has to be a plus and a minus in some type of order. So that's just one thing I would like to add. So those are our A values. So we're going to kind of stray away from them. Like these just take practice. So let's do some of the other ones. So a unique one would be, let's see, I think I wrote here 4x squared minus 1. So you have only two terms, so you should be suspicious because in your head you should say, huh, this is called difference of squares because our middle term is a 0x. So I know I'm going to have two parentheses, a plus and a minus, and both parentheses need to be the same. Okay, so you have that in the back of your head. But the first thing that we should always check for is GCF. And if I look, 4 and 1 both don't have something in common. I mean, they do have one in common, but nothing that can help simplify this. So now I have to ask myself, how can I rewrite this like this? So what two same terms multiply to give me 4x squared? I hope that you see that's 2x. That 2x times 2x gives you 4x squared. What two numbers multiply to give you 1? Well, that's 1. That's a 1 and 1. So this ends up being our answer, 2x plus 1 times 2x minus 1. But let's say that you don't believe me. Remember, you can always check your work. So actually, let me take away the 2 on the bottom real quick. So let's just do 2x times 2x is 4x squared. 2x times negative 1 is negative 2x. So you took your first term and you multiplied each term in the second parentheses. Then what you do is you take 1 and you multiply it by each term here. And you get plus 2x minus 1, and you get the same thing that you started off with, which is 4x squared minus 1. So that is how you would approach that problem. So let's do one more problem, and let's do a problem that involves a negative sign because this can be confusing. So one thing I would say is I really do not like having an A value that is negative. Not to say that you're not allowed to do it, but I just think doing this is better when your A value is positive. So I have two choices here. If I'm going to factor out the negative 1 regardless, that's what I would always do. So let's say that it was negative 5x squared minus 1, let's say minus 100. Oh, that doesn't work. Let's see. Minus 11. Let's say that we had something like this. This doesn't factor. I know it's not the best example, but I just want to prove a point here. I don't like this being negative. So in this example, I would factor out a negative 1. And negative 1 times what gives you negative 5x squared? Well, that's 5x squared. Negative 1 times what gives me negative 11? Well, that's plus 11. So I hope you see that you can do a lot in math as long as you don't break rules. So here, all I did was factor out a negative 1, and that makes me happy because this 5 ends up being positive and something that is a little easier to deal with. Once again, 5x squared plus 11, you can't factor that, but I just wanted to show you how to factor out a negative 1. So, going back to this example, there's two things that you can factor out. Not only can you factor out like a negative 1, you can actually factor out a number. So instead of factoring them out separately, we're going to do it together. So 3 and 27 both have 3 in common. So I'm actually going to factor out a negative 3. Negative 3 times what gives you negative 3x squared? X squared. Negative 3 times what gives you positive 27? Negative 9. Once again, the best thing about this is you can always check your work, especially with this sign. Like, why, Miss Joseph? Why did he change it? Well, negative 3 times negative 9 is what gives me a positive 27. So that's why I had to make it negative. So, a lot of you, once again, want to call it a day, but you should notice that you're not done with this. This is also a difference of squares, and it would be x minus 3 and x plus 3. So that's my video for today. I hope this helps. If you have any questions, feel free to ask me. But I just wanted to do a couple questions to kind of help you out. Have a great day.